Okay, so we are live. Welcome to episode 4 of building an emulator, and Gameboy Emulator with Rust. Today we're gonna continue working on our opcodes, but first let me address two things that was mentioned by one comment in YouTube. So I appreciate that we have commenters. Oh, let me put some music here. They're gonna put some. Don't know. Let me put some. Okay. Too high. Okay. So in my last video we built, in our last session we started we did this refactor. So first of all, I think we can use here just pub mod. Then I think we don't need to use this. Let me think if it is still run. Nope. It is because need to use yeah, and I think that will be enough. Nope. Yeah. And I think it needs to do this. And now it's working. We stopped it in the bit 7, but this is not the thing that this guy named it Saturnum Zimarts suggested. He said there are a couple of things that I want to tell you. One, with the instruction LD HLI, a decrement if HL is 0 will cause a panic. Yeah, and he is right, because if we do this in the execution part here, this could panic. So what we will do, we will do this equals to HL dot wrapping sub. I think that's fine. Yeah, still the same. Let me see if it's still the same. Yeah. So if instead I did this, I do it should be the same, right? No. For 9059. Yeah, the same. So with this wrapping sub, if it's 0, it will wrapping the 16-bit address, and then 000 will become FF. Okay, so this is solved. The second is with the instruction of the group CB 7C. I think it would be better than use a U8. You put a bit of mask. What he's telling us here is that here in the instruction, instead of me passing this U8, I can put a bit mask. Yeah, something like this. Like if it's 7, like this. 0, 1, 1, 1. But that will do the same, not the same, but yeah. So instead of this number is not. If we now go to the, yeah, this is obvious not 7. It is 128. 128. Yeah. Yeah. 0, 0. No. 0. Let me see. 0, 1, 0, 0. It's 8. 1, 2, 3, 4, 5, 6, 7, 8. So 6. $64 actually. Yeah, 64. So this is a 64. 2, 4, 8, 16, 32. Well, 0. Actually, 1, 2, 4, 8, 16, 32, 64, 128. Yeah, 1, 1, 1. Yeah. So his idea with this is passing a bit mask. Now in the bit, now when I execute in bit 8, I think this is his idea, because now I can do something like, it is still U8, but not the absolute value where the bit is. But with this I can just do an logical, a bitwise operation with this, because I'm marking where, which bit this instruction is tied for. So this is the bit in 7. Yeah, 8, 7. So the bit, this instruction is this. Yeah, I will work with that. So and this bit 7. So let's go there. Execute. So then this. Let me finish with this bit 7. Then I will do something. I have two things that I want to do. But let me finish this because we stopped in the last episode. We left on doing this first CP instruction. So this is a 07C. 07C is this bit 8, where 7 is this. So this is the decoding. I mean returning the instruction. Now I can do this. So I can do this instruction bit 8. Oh, of course. 8 brings bit mask. Now this it bringing a bit mask. Well, we know this is 1 with CB and 2. So I'm not sure if we will increment by 3 the self PC or increment by 2. Let's try by 3. Self PC. Why? Because 1 from here and 1 from here, 2 from here. Oh, we also forgot one other thing here. Update the flags on register F. Remember that? We need to do this in every arithmetical instruction. This documentation does not say nothing about that, but in this case, but I think we need to do. But that's it there for a while. Let's get back to the bit mask here. So this bit mask is just this. Set Z if bit of bit register. So in this case is H. So self. How we wanna get? Oh, I know. Actually, the bit mask should be different. Should be the reverse. Oh no, this way is good. How? So if we do so this is the bit mask. In this case it will be 0. So it will be 0 1 0 0 1 2 3 4 5 6 7 8. So this is the bit mask. Let's say that self H is something like this. So if we do an bitwise Y, it will be 0 1 0 0 0. If this is 0, it is still be 1, so that is not our So if I do the sure, it will be yes. If it's 0 0 1 1, yeah, I think that's it, because if it's 0, then this bit will be 0 as well. So yeah. So so I need to test. Sorry guys, sorry people, sorry. Why is that? Let me see, what is the problem? Okay, so here will be something like this. First, let's see if this is if bit B of hash set if B. Okay, so let's see how. So let bit test equals to self 8 bit mask. So then if bit mask equals to bit test, if the mask is equals to bit test, it means that the bit the B the bit b equals 1, else the bit be different one. Okay, so I think it do not exist here. Okay. Yeah. Let me do what you ate. What's the problem? Okay. So if the bit what's the problem here? So if the bit mask is equals to bit test, it means that bit is equals to 1. Yes, it is true. Okay, then. But first of all, we can set the other flags from the register F. How I did that? Ah, yeah, I did this way. So previously, I set the register using this, right? Yeah. Yeah. So let me do something here. Print on equals. Okay. 1, 0. Okay, but I want to print. How do print Rust print in binary? B. Okay, so should do this. With bit mask. Actually, can't do this here. Bit mask and bit test, right? So then 1 and 0. Yeah, because they are different. Yeah. Because if I do H so if you see the 11th The seventh bit is 0. So bit mask is this one, and bit test is 0. So bit test is 0. So okay. So then we have this bit mask done. Yeah. We are able to actually now set the bit. So the result of this bit operation is set Z flag. Z flag, as I remember, is the first bit of self F. So let me just print here elf just to myself. If you see here, self F. So right now, the Z is set to yes, to 1. Yeah. Because of other instructions. But now I want to how can I set a bit? So we have I think, yeah. Now it's time to build something better. Yeah. So F is here, right? So it's better to us to have a way for setting the bits, right? So let me, so I want to set, no, it's not, set, so get Z. Yeah, I will end up needing something like this. Well, not more table, of course. Which will return a bit. Rust has a bit. Bit data type Rust. I don't think so. Integer. Oh, yeah, well, of course there's a bit. Shame on me! Shame, 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 shame. So I need to see if it's a bug. So let's do this. I need to set. I need a way to get Z. So Z and H and C, and the same for setting. But for set, I will need to receive the bit then, right? Which will be boo, and will return nothing. But in this case, it is a mutable self, right? this case it's let me put this Z flag, N flag, 8 flag, C flag, so flag, because we have the register H. I don't want to mess with that. Okay, in this case, how we get that? Well, this way it's easy. Well, self f a 0 1 0 0 b 1 1 2 3 4 5 6 7 8. So 1 2 3 4 5 6 7 8. Yeah. If we do this way, what's the problem here? Oh, yeah. I think I need to do this. Is there a way for doing that? Oh, of course, my horse. Still not a bull, still not a bull, still not a bull, still not a bull, still not a bull. Yeah, I think it should be 7 then. Let me do something here. Let me do some testing. Let me do some testing here. So this, so let me see if this, what is this happen? I think it's 7, but it's the other way around. Yeah. So we are just doing rotate the flag. Yeah. So 6 it will be 1 2 3 4 5 6 7 it will be here. So yeah, so it's 7. So if I need to get this a flag, I will do 7, but this way and do as bool. I do this. Why it's that? Anyway, okay, so let me do this. Let Z flag equals to Z flag as equals to, so let f F E 0 B 1 1 1 1. I don't like this music. Too sad. Great. And simpler. Okay. So this is good. Yeah, this is good. So only Z on F. So I remove the other 0 1. Okay. 1 2 3 4. 1 2 3 4. So this way. Okay. Then I do that Z flag equals to on 7, and then Z flag as actually I can do this. This is the problem, I think so. Okay. How can I convert? Oh yeah. This way. Ta-da! Okay, I got the Z flag. So now I have a way for doing N flag. So well, if you find these two, of course we can do that one line, but I think it's better, at least for me, to reason about it later. Well, I used this reason to get there, so why not let it here? The compiler will take care of that anyway, so I think so. At least I think so. So doesn't matter the size, but the legibility, like the readability, if it's readability. So okay. What's that? Let's see. Okay, it's never use it. I know that's never use it. But it's there for somebody that wants to use it. So now I need a way for setting the Z flag. So how to set the Z flag? Huh? How to set the Z flag? So for setting the Z flag, so before setting the Z flag, I will do this. I will again well, it to be more precise, I can use this, not a bool. So there is a set and a reset. Set is 0 and reset. Set is 0 and the reset is, well, set is 1 and reset is. Why that? Because that is the way people used to call setting and resetting flags. So okay, so in this case I need to put 1. Set Z flag to 1. I will just put this here. Set Z flag to 0. Okay, no problem. So how to set I can do this self F equals to self F some resource rust set to U8 bit. Whoa, look at this. Is this from trade bits? Who implemented trade bits? So it's already there. The mask is already there. So if I want to do this, like Z on F, we'll do self F dot get Yeah, I saw. This is a bit back. Homepage, let's see. Nice. Nice. It's pretty nice, but actually I want to do this myself. So yeah, this is not available. So let me get back to the get and set. And I want to set. Let me use this notation here because it's nice. Much more readable. So we are able to get the flag, yeah. So actually we can do it differently. Yeah, if we do an R, if we do an R with 0, yeah. So for doing this, it's easier. Self f equals to self f or 0b 1 0 0 0 0 0. Well, I don't need to return nothing. Why? Because this will be 1 even if it's 0. This will be whatever it is, this will be whatever it is, this will be yeah. There is no way easier from doing this. Okay, reset. No, this is set. This is reset. Sorry. So this will be this, of course, because all the ones will be whatever it is, and 0 will be 0. Nice. Yeah, it's not too hard. Wow. So this is this. Okay. And we have this. Which is this. And we have this. Which is this. And then we have this. Okay, so now we have the methods to set and reset all the flags, which is nice. So now it's easy. So here we do. If it's set, what I should do? If it is set, we do self set. If it be of it is set if b of a register. Oh, so we set in this case. So we set, and we always reset, and we always set the H flag. Okay. So we set if b is if b of register is 0. So okay. Now we have this, and this is an bitch H. So yeah. A bunch of code repeated here. Okay, let's say it's okay. So this, but I want to execute the other bit, all the bit. I want to do this for all this bit. Actually, but I want to do that for all the registers. I will do. Okay. Let me do this for a while. This is a bit of shame, but okay. Okay. No. Okay, this is okay for now. B, bit C, bit E. Okay, so we don't have this. Okay, we are not ready to do bit yet. It's too far here, so no problem. So okay. So let me get back to here, which was yesterday. So this increment, decrement, CPU, Where are those? AD. Yeah, this. Put A in memory, decrement HL. I decrement HL. Okay, so let me see. What I mean is, if it should I backtrack? There can't be. But I'm not sure if these registers, if the flags applied for when I use, because this is a special instruction when I decrement HL directly. Actually, it is this. Set if reset is 0. If the result is 0, set. Okay, so I can use this. So if HL is 0, if HL equals 0, then self set the flag okay, don't need this. Is 0, set the flag, set and flag. Set if no borrow from zip. I think this is the case where I'm not sure how to deal with this. So if I do wrapping, if this wrap, I should set this to wrap. So pressed. Wrapping, so okay. So actually, if HL is 0 now, well, this way I will be able to see, right? If HL is 0, it will do and it will borrow the carrying the bit. Not for bit 4, not for bit 7, bit 4, but let's see. Okay, so now we are okay. We did a lot here. so let me see. Okay, so one thing that I would like to go. So this is the assembly of the ROM that we are running. Okay, this one. So if only if seeing that we have problems there. Still there? There, yeah. Nobody's talking in the chat, but it doesn't mean that there is nobody watching. Anyway, continuing here, I have this oh, this follower goal is weird. It's right there. How can I reset this? We would have follow. It seems that we have some problems. Okay. Okay, so let me do this. Okay, back. So FB, let me check where we are. Is this FB? FB, let's see if it's FB. What is FB? FB. No, I'm pretty sure that this is not FB. So actually this, I think it's the problem that, so that's why I said I think this sure this bit code is not 3 but 2. Zero 20. Yeah, it's because the jump, this jump is this one. Okay, so just to understand what I did, I just decrement the, I just fixed the PC. The opcode instruction actually do not take the CB stuff, do not take what is in CB, which is 1, plus what is in this, but only what is here. So this bit is 2, so it takes 2. I need to increment 2 in the program counter, And then we found the instruction number 20, 020, which is here. And this by our decompile that we already had. So this is like a sheet, right? Because we are already knowing what is, but this is good for us, at least for doing this first instruction set. So we have this JR. Let's go to here and see what is those JR. I think JR is jump. Then we're gonna need the stack, and so jump to address container in HL. But in this case, it's not jump, it's jump and Z. Okay, jump GRZ. Jump if and Z flag is reset. So if the L and Z flag is reset. So I want to do something here. I want to do the two things. You see that in our decoding, we are dumping our CPU state, the current byte. So we have the CPU state here. But for example, we don't know the NZ because we are dumping the completely. So I can do one thing here. I think I can implement debugger. How to implement debugger? Implement debug rust. So here if I do a derive, yeah. If I do this, actually I did already. So yeah, here. But I want to. So I need to do this. Use standard format, and then I want to implement my own debug. I will do this first. Implement format debug for CPU. Okay. Now it is yourself. I'm a table. Copy this here. So what should I do here? I should write what I want to. So I will do this CPU. It should be A, but all should be as an. So let me do this. A, B, so self A, self B. Okay. Self C, C, D, E, E, G. Then we have F. I will just skip F for a while. We have H, and we have L, then I want to check the flags. Okay, so we'll do this way just to be pretty nice. So CPU will be this, and will be this. I think I can do this. Can I? Yeah, I can. And I can do this as well. So here I do flags. Then Z flag, I will do this. It will be like this anyway. So Z, what are the flags? Gosh, what happened? So Z and I can do this uppercase then, right? A, B, C, D, E, H, L, flag Z, and H and C, right? Right. So then it's self B, self C, self D, self E, self H, self L, self get Z flag, self get N flag, self get H flag, and self get C flag, and then we are good. I think now it's better. Let me see. Nope. Okay, yeah. I need to remove the debug. Okay. Need 2 here. I think so. This is the problem. Let's see. No. Oh, I don't think this is possible. Maybe. Oh, yeah. This. Okay, so. Okay, so A, B, C, D, 9F, F, E, true, false, false is false. Why it's true? It should be true at this point. It should be true at this point. Yes or no? So it's saying that this is true. Okay. Oh, this is something. Okay, 0. Okay, so this instruction, it says nz jump if jump z flag if z flag is reset. So yeah, we're gonna jump because no, we will not jump because the flag is not reset. Anyway, I need to implement the instruction, right? So let's do it. For doing this, I need to first create the instruction here, like jr nz, and this brings 1.8. This is the following 8 bits. What is right? This is something else. It means 8-bit signed data. Oh yeah, because this is add and to the current address. This is interesting. And this says that this is signed data. Which is where? Because If it is assigned data, it will be only. It should be E. Let's do this. E. Let's see what's that. This is something here, 18. The same, but this is not NZ. Well, if you put here, no problem. Then we will see if that is needed or not. Okay. So then in GR. I think I can put JR and Z. JRZ. It should have a JRZ, right? JRZ is 28. Let me see if JRZ 28. So the 28. So then JRZ. Okay. So I will do all GR, so GRZ, GR and C, and GR C. This test Z, this test C. Z and C flag. Okay. So getting back here to the code. That's the code is instruction, which is 020, which is kind of here. So 020. I think it will get yeah. So anyone? Okay, let's do this. So instruction JR and Z and new one as UA. $28 is your Z, just Z. 30 is your NC, and 38 it's turnover. Okay. So then if you go, it says, okay, I don't know how to jump. I don't know how to do this. This is nice. This is nice. Because it is 05. Here it says jump address 007. Oh, now I think I'm missing something. Let me me do this. Let's go here and put y. I think then it will be there. -5. -5. Let me do this. In execution part of this, you do this instruction. See. This is FB. Oh, yeah. Should we add to program count? So if I do this, self, see, and then n plus self PC, and then self PC equals to n. Self PC plus n. Let's see. Wait. Okay, so now I'm just debugging here. Yeah, I'm just debugging. Okay, what happened here? Attempt to add with an overflow. Should be wrapping add and as U8. Let's use 16. What's the problem now? Oh yeah. Maybe. Yeah. So maybe this 05. This is not correct because it should be 007. So something is weird. Something is weird. What is SU16? I'm having problem here to convert this number. So I need this is not right. So it should be what it is, which is not FB. It's -5. Okay. Let me do something here. Self PC is 10.
That's just love. I would never let you down. That's just love. And you keep on thinking that's just love. That's just love.
Well, one thing here.
I would never let you down.
Let's put this as U.
And you keep on thinking that's just love.
So in the decode, still 10.
That's just love. I would never let you down. That's just love.
Still 10. Oh, wait. So this is not okay. So NZ under 77. This is getting hard. So here I need to get CC, okay, and then add n to the current address and jump to it. So I need to add to the current address. Okay, so let me recap what I'm doing here. So 020 is GR and Z. Okay, I'm getting the next 8 bits. Okay, because I'm reading a byte, so I'm reading as U8. Okay, even as I put a U16 here, I'm converting back to U8. So anyway, it will be 8. So when I'm executing this, which is here, I'm printing it. Let's print it as a U8. So n is 251. If I print this as an unsigned 8, it will be -5. At this point, the program counter is 10. Let's print this as this. Okay, so the program counter is A, because we are here. I need to increment if the following condition is true. Okay, I'm ignoring this if for a while. So let's do not forget this. So if, in case of gr and z, if self get, if jump if z flag is reset, if this, so if not, so if this is not true, I would do this. Okay, I don't need this, I don't need this. Okay, so yeah, okay, this is a queue, but the problem here, why I'm confused, because as I said, we are using the disassembly of the ROM that we are loading as a blueprint, as a way, I mean, to see if the instruction, the code and executing is right. It says that okay, it's a jumper and z to address 0007. which means that the result of adding n to PC should be 0007. But our sum is saying 105 0105. So something is wrong. C8. Let me see something here. Doing this just to stop the program there. Even if I put it way, it will continue. Of course, because it's positive, it will continue. So let me try to finish this before wrapping up this session. I need to be able to do this. So why? So if I sum Rust, how to operate but anyway, well, if this is minus 5, if the program counter unless let me see one thing here. Wait. Yeah, because G. Okay, so I think what it means is this. Let's see. So self PC. Let's do this first. So self PC equals self PC plus 2, because it's the size of that. Okay. So then let's see. Self PC wrapping and as U16 and see what it gets. $107. Now it's something else. Let me see. Okay, now 12 minus 5 is 7. So then okay, so actually let's put this as U8. Let's put this as a U8. It isn't U8. Self PC. It's an U16. Actually. Just because this okay, this is an unsigned inter as it is described what happens if I do this? Oh, thank you, Anti-Aware, for the follow. Thank you. I appreciate that. I really appreciate that. So I need an idea here because so I have this. I will tell you. I have this. Okay. So PC is U16, N is unsigned int, or it should be. Okay, let me see if that's the problem. Because if that's the problem, okay, so let's put this way. Okay. Okay, why? Because in the documentation it says that it is unsigned inter. So let's leave it this way. Anyway, if you get here, you will have the same problem. Okay. Oh, the sum now it's 7. Yeah, the problem was wrong. Yeah. So the problem was that this was an assigned integers. So if you see here, no, it's okay. Now we're up C. but why it is looping? Because we are returning to the same point where we were before, because we should not do this unless the flag is dead. Yeah, if we jump, then we go there. Oh, but there is one thing here. When we jump, we need to put a point back. A jump needs to put the current PC, so self PC, no, self FCP. Right. I should be able to stack pointer. Special register. So stack pointers. Let's see if there's stack pointer. If a generation support. Okay, let me go. Jump marshal differences. Wow. For using stack, it should use call and head. Jump has nothing to do with stack, of course, because jump is just a if and not a function call. Yeah, jump is a branch, not a function call. So there is nothing to do here. So yeah, I think if now we do this, okay. So we just did that. I can do the same here with JZ, but instead it will be like this, and JNC will be like this, and JC will be like this. So we have more opcodes done. Yeah, it's late already, so yeah, 2 hours. I think it's good enough. I'm just curious about the next. So OE 0 we. I think we are here. How is that? Should not be here. Oh, I think this structure we know already. Let me check. Oh yeah, load HL. I think we know load HL. we know it. So this is why we are zero F. Yeah, we are here. This is a zero E. So E. It's E. Oh, let me do something here. Right, we have our self PC and self SP. PC SP zero F. Okay, so zero E. So E0. E0. I don't think that is where we are. It should be load C 0E. Ah. Oh yeah, because it's E, the 0, yeah. So it's 0 E. Yeah, load C. I think this is it. Yeah. We already did something of this. Load BC, load. Wow. So let's do the load. So load B. Load C. Load L and load L. Okay. Okay, and did the code. So here. Well, here I don't think we need that anymore, right? I can do this and this, and this will be enough. Then I can just do this. So something like 006 instruction load B and 1 because it's U8. Yeah. So then UE, this is load C, this is load D, oh sorry, OE16 is 1E, but this is D, this is E, and this is H. No, this is 26, and the register H, and this is E, and register L. For doing that, I will be doing this, 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 anyway, either way is fine. That is what. Okay. So all loads, if we run now, it will say that he recognized it to load 17, which is fine. We are doing good. We are doing good. We are doing good. I think if we finish this, it will go through this increment. And go there. Yeah. But anyway, it's a red dot. So let me. Well, we did not had time to do display today. Yeah, we are doing sessions like 2-hour sessions. We are already in 2:10. It's late here. I need to drop. So let's commit this status git add git commit. So add more opcodes and some debug, git push. So everybody, I'm pushing my code to my git. So git gb. So my code, this code will be, is actually a red. Douglas Correa GB Rust emu. You can call it gibrust emu. And yeah, we added more opcodes. So let me just quickly review what we did. Well, we implemented more. What I just did was put this pub mod to avoid that pub use. I also I create these functions to get the flags and to set the flags. Which flags? These flags. The flags that are on the register F. So NZ. So I put the function here to use that flags, to get those flags, and to get those flags, and to set those flags. I also implement debug for CPU just to have these flags exposed. So now when we run our code, and it will always panic when there are no decoded instruction or there are no implemented instruction, as we already saw. But now it will just show the flags as well, because register F doesn't matter as an 8, as an integer 8, but it matters as a flag. So right now the flags are true, false, false, false. Yeah, and then we implemented some other instructions. As I said, we are loading the boot ROM, which is this file, which should only display the Nintendo logo. We have a blueprint because somebody else already disassembled this, so we are following up with this disassembled boot code just to be sure that we are doing right our disassembly, and we are already here. So we are implementing the instructions as we are reading the file. So we are already here. It will be implemented here. So we already set up our memory, and now we are set up in audio memory. Tomorrow I think I will do some refactoring in the MMU, because I created the run as an array of 64 kilobytes, and that's a good representation. But I think this is good. This is a simple representation actually, but I think we can do at least some methods to get the information from those special areas, because as we saw in the first and second episode, the memory is divided by special areas, and this video run is where those tile sets and background will be. So it's very good to us to see what's there. And also this IO run is some kind of a registers stored in IO, so it's also good to us to see what's there. Actually, all those top level run. So I will be building this debug tomorrow as well, just to us to see while we are implementing this. Then we are able to at least debug and see what's going on in the memory level. So that's it, guys. It will be uploaded to this video will be uploaded to my YouTube channel. So anyone that is watching now and want to see the other videos, they are all there in my YouTube channel. So I'm creating this list, building a Gameboy emulator with Rust, which I'm updating daily with the videos that I just did here. Okay, so see you tomorrow, and thank you for watching. Yes.